Hello, this is a little video for you in intermediate algebra for some review problems and examples for you to look at and practice before you take your Chapter 2 test. So here's an example of something like problem number 1. So 1, 5, 1, 7, etc. Now, the question says, is this a function? Is this a function? Well, look carefully at those points. Remember, this is x and this is y. So that means that if you plug 1 into the function, if it's a function, we don't know if it's a function, but if it were a function and you plugged 1 in, then you would get 5. But this means that if it were a function and you plugged 1 in, then your y value, the answer you'd get would be 7. But that's impossible though. When you have a function or a formula of math, and when you plug in one number into that formula, you'll get out another number. But if you plug in the same number again, you cannot get a different number out. So if this is true, then this cannot be true. And if this is true, then this cannot be true. So that's a contradiction. So this problem right here, it's impossible for it to be a function. So the answer is, if it says, is this a function? The answer is no, it is not a function at all. However, though, the range of it, so let's look at the other points. The other points are 4, 5, and 4, 7. So the range of it, it still has a range, even though it's not a function. The range of it is equal to the numbers that are the y values. So that would be 5 and 7. All right, so that's number 1, an example like number 1. Now let's try a problem like number 2. So number 2, their formula is 7x minus 1. So it actually says g of x equals 7x minus 1. So what does it mean to say g of 0? You plug in 0 for x, and you would get 7 times 0 minus 1, which equals 0 minus 1, which equals negative 1. So that's negative 1. And then the next one, you'd plug in negative 2. So I'll just let you do that one by yourself. How about the third one? You have to plug in a fraction. So I'm going to show you that one. So if you plug in a fraction into it, that means you take the 7x minus 1 and you plug in for the x, you plug in the fraction. Now, what's 7 times 1 seventh? That would equal 7 sevenths, right? So 7, because you see 7 is really 7 over 1. So if you do 7 times 1 on top, you get 7. If you do 1 times 7 on the bottom, you also get 7. So then you have 7 over 7. And 7 over 7 is really just 1. So then you have 1 minus 1, which equals 0. Okay, then how about the next part of this problem? It says g of negative 9b. Well, that just means you take the 7x minus 1, 7x minus 1, but instead of x, though, you erase the x and you plug in negative 9b. So if you plug in negative 9b into it, you just multiply by 7, so you get negative 63b minus 1, and that's it. That's the answer. So then, last part of this problem says g of b plus 5, something like that. So once again, you have the problem 7x minus 1, and when you plug something in, you just take the place of the x, and then you put the thing in that you're plugging in. So you plug in b plus 5 instead of x. Then you multiply the part that you plugged in. Anything in parentheses, you multiply by what's outside the parentheses. That's called distributing. So 7 times b is 7b, and then 7 times 5 is 35, and then you still have the minus 1 at the end. So you have 7b plus 35 minus 1, which is really equal to 7b plus 34. So the answer is 7b plus 34. All right. Then, number 3. This problem number 3 is something like this. F of x equals x squared, and g of x equals x squared plus 6. So the graph of the functions is just like this. X squared first, And then you have the same. Now notice x squared is the same. The only difference is you've added 6 to it. So the next function's graph, I'll do it in red. So the graph of this new function right here is just going to be the graph of the old function with 6 added onto it. So if I go 1, 2, 3, 4, 5, 6, and I start from there, and I go from here, I go 1, 2, 3, 4, 5, 6, and I go there. And then from here, I go 1, 2, 3, 4, 5, 6, and I go there. So the new graph is the exact same as the old graph. It's just shifted up by 6 units. That's the answer to the second part of the question as well. So really the answer to the first part is also kind of the answer to the second part. If you understand how to get the graph by shifting it up 6 units, then that's also the answer to part B of the problem. Okay, then problem number 4. So problem number 4, it shows you a graph. Now it says use the vertical line test to identify whether y is a function of x or if y is not a function of x. So what you do is you try to draw a vertical line that touches the graph more than once. So there we, whoops, hold on, let me erase that. Let me change color. So if I draw that line through the graph, does that green line touch the graph more than once? Yes, it touches the graph more than once. So if you can draw a vertical line through a graph more than once, that touches more than once, then that means that the graph means that y is not a function of x. Y is not a function of x. Because the vertical line goes through the graph more than once. Okay, so then problem number 5. So problem number 5 shows you something that's kind of like that. And then notice that if you look at the scale of the graph, there's several different markings, but the only one that matters for me is that one, which is 3. Because it says, use the graph, in problem 5 it says, use the graph to find f of 3. So how do I look at that strange looking graph, and then how do I find out what f of 3 is? Well, I look at the 3 on the x-axis, right? Because 3 is x, and there's 3. Now what I do is that I also look at the y-axis, and I look to see where that line that's at 3, the x value of 3, where that line touches the graph. So it touches the graph at that dot right there. Then I look back on the y-axis, and then I'm like, oh wow, that little dot touches the y-axis. So on my graph, it hits the y-axis at 2. And so therefore, that means that when the x value is 3, the value of the graph has a y value. At that same point, the y value is 2. So the answer would be f of 3 equals 2. Now your answer is going to be probably different because your graph might look different. But that's how you figure it out though. Okay, then next question. Problem 6. So problem 6 also shows a strange looking graph, just random or whatever. And this one says though, g of x equals -3. So this graph already says g of x equals -3. But then the question that you're supposed to find out is, what does x equal? X equals blank. So this time we know what the y value is. We know g of x equals -3, but we don't know. We do not know. There's a question mark right there. We don't know what the x value is. So really, we're trying to find that an unknown x value. G of what? G of what in the world equals -3, right? Well, we know g of x equals -3, right? But we don't know the x. So let's look carefully. So what's this -3? That's -3 is the y. So what we're going to do is look at the y-axis. Look at the y-axis to find out when the y-axis is equal to -3. So on my graph, the y-axis is -3 right down there. And then I go along that line of -3 until it touches the graph. So I go along the line of where y is -3, which is down at -3. And I move that line along at the same distance down all the way across until it touches the graph. Now what I do, I look over where it touches the graph, and then I look up straight up to find out what x value it touches. So that would be on my graph, that value is actually at 4. So the x value on the x-axis that touches down to that point right there, that x value is 4, right? So x equals 4 when g of x equals -3. So the answer to your question, therefore, would be 4. So that would be your answer. Perfect. Then problem number 7. This one also has a strange looking graph. This time the graph is flat and then it goes down. And the value of it when it's flat happens just to be at 1, 2, -3, right? -3. And then it goes down. So it says find the domain and find the range. So the domain, remember domain means what are the x values? Well, x values are along the x-axis, right? Which means left to right. So if I look at the left side of this graph, it goes left. That arrow means it goes left forever to -infinity. Then if I go right, the arrow on the right means it goes to +infinity. So the domain, therefore, goes from -infinity to +infinity. So that would be your answer for the domain. Then let's find the range. So the range, what's the range? The range is the set of y values of the graph. Well, the y values are on the y-axis. So there's the top of the y-axis right there, and then there's the bottom of the y-axis. Now, if we look at the top of the y-axis, the graph is not going towards the top of the y-axis, right? The graph is only going left, and the graph is completely flat. So the graph never goes any higher up than -3. So the highest it ever goes is to -3. But the graph does start to go down. It goes down, down, down toward, and if it goes down forever, it'll get to -infinity. So the y values of the graph, the lowest they go are to -infinity, and the highest the y values go are to -3. Now it does actually touch -3 and so you'll put a bracket beside -3, meaning that it touches -3. So the range looks like that. Okay, now let's try problem number 8. So problem number 8 says, find the domain. So what's the domain of that function? Well, remember a domain is the x values that you can plug in, right? From left to right. So if I draw a number line, like an x-axis, I can pretty much plug in almost any x value for all the way from -infinity, right? All the way to +infinity or not. Do you think I could do that? No. Well, almost. I could almost do it. But there is one x value that I cannot put into that fraction. What x value would be like a big red no that I could not plug in? I could not plug in 12, right? Because if I plugged in 12 for this, notice that you see there is in the problem there's also a -12. So if I plugged in for x a +12, then I would have 12 minus 12, which would be 0, right? And you'd have 0 in the bottom of the fraction, which is not allowed. So you cannot have 12. So that means that I need to raise this -infinity to infinity, and I need to raise this graph a little bit, and I need to put a little dot at 12, an open dot, meaning that I cannot plug in 12. So x can never be 12, but x can be any other number except for 12. So really, the domain of it starts out over here at -infinity. Then it goes to there and stops. Then it goes to here and stops. Then it goes to +infinity. So the domain is -infinity through +12, or it could go from 12 to infinity. And 12 is not included. And since 12 is not included, then we use parentheses and we do not use brackets. So that would be domain. Okay, perfect. Now, let's look at number 9. Number 9 says f of x equals x squared minus 5x, and g of x equals 9 minus x. So find f minus g of x. So that just means you subtract them. So if I do x squared minus 5x, and then I subtract g of x, so I basically just take my f of x, which is this, and then I subtract the g of x. Now, when you subtract something that has multiple parts, like 9 minus x is 2 different parts. If you subtract something that has multiple parts, then you need to put those in parentheses. So when you do f of x, that's x squared minus 5x. And then when you do minus g of x, you have to put parentheses around the g of x, which is 9 minus x. Then you distribute this negative, so you get negative 9, and then you get positive x. So then you have x squared minus 5x. You have x squared minus 5x minus 9 plus x. So then you get x squared minus 5x, combine this term with this term, so you get negative 4x minus 9. So that is your solution. So that's the answer to that. Now, and then there's a part B in this problem as well. So the part B says, what is f minus g of 4? So what you do is, you can just plug in 4 into that answer. So if you plug in 4 for x, you get 4 squared minus 4 times 4, because x is 4. And then you have 4 squared is 16, minus 4 times 4 is negative 16, minus 9. 16 minus 16 is 0, so you just get negative 9. All right, now let's go to problem number 10. So 10 says f of x equals x squared minus 3x, and g of x equals 7 minus x. Then it says find fg of 7. So there's 2 ways of doing this. If you wanted to, you could multiply f and g together, right? You could take f multiplied by g, right? You could do that. If I did that, though, that would be called fg of x, right? But what it wants me to do is it wants me to find fg of 7. So what I need to do is erase this x and plug in 7, right? So I need to erase this x as well and plug in 7 for that as well. And then I need to erase this x and plug in 7 for that. And then erase this x and plug in 7 for that. Now, 7 squared is 49. 3 times 7 is 21. 7 minus 7 is 0. And 49 minus 21 is 28. So you have 28 times 0. Now what's 28 times 0? It's just 0, right? So that just equals 0. So f of g of 7 is just equal to 0 for my problem. So on your problem, it might be a little bit different, possibly. All right, now let's try to do number 11. So this one says f of x equals x squared plus 8, x, g of x equals 5 minus x. So what is f over g of x? Well, all that means is you just take the formula of f of x, which is that, and you put it over the formula for g of x. So f over g of x is just x squared plus 8x over 5 minus x. Then, now we need to find f over g of 7. So what you do is you take f over g of x, and then you plug in 7. So it's going to be 7 instead of x, and then squared. And then in the bottom, like 5 minus 7, right? So I'm going to change the color of the 7. So we're plugging in 7 everywhere that there is an x. And then 7 squared is 49, plus 8 times 7 is 56. And 5 minus 7 in the bottom is negative 2. So I have 49 plus 56, which is 105, divided by negative 2. So there we go. That's the answer, 105 divided by negative 2. All right, now let's try problem number 12. It says 3x minus 4y equals 12. So we're supposed to plot the intercepts to graph this equation. So we're going to make a little chart. So for my y value, I'm going to just plug in 0. If I plug in 0 into the y value, this part of it's going to be gone. So it goes away. So the only thing left is 3x equals 12, right? Now, 3 times what equals 12, right? X would have to equal 4, right? So the x-intercept is 4. So I'm going to make a graph. Now on the x-axis, I'm going to plot x equals 4 on the x-axis. Then I need to find the y-intercept. So to find the y-intercept, you plug in 0 for x. If I plug in 0 for x, then you see, plug in 0 for x, then that means that x is going to be 0. So that part right there just cancels out. So the only thing left is negative 4y equals 12. If I divide both sides by negative 4, well, you get negative 3, right? So y has to be negative 3, because negative 4 times y equals 12, and negative 4 times negative 3 equals 12. So the only thing that y could be would be negative 3. So the y-intercept is negative 3. So on the y-axis, I'm going to plot negative 3. So then you draw the line through those 2 points. Sorry, I'm getting off track. You try to draw a straight line through those 2 points. Like that. And then there is the straight line. All right, now let's try to do number 13. Three, 4, 4, 8. So we have to find the slope of the line passing through these points. So the slope formula is m, which sort of stands for a French word that means like mountain. So mountains have slopes, right? So the slope is called m. And the formula for the slope is the second value of y minus the first value of y divided by the second value of x minus the first value of x. And the abbreviations they use for the second value of y, it's called y2. And then y1 means the first value of y, and so forth. So the slope is equal to the second value of y, which is 8, minus the first value of y, which is 4, divided by the second value of x, which is 4, minus the first value of x, which is 3. So 8 minus 4 is 4, 4 minus 3 is 1, and you get 4 divided by 1, which is 4. So the slope equals 4. Now, is that a positive slope? What do you think? Yeah, it's positive, right? So the next question says, is it going to be horizontal, vertical, or is it going to be falling or rising? So since the slope is positive, that means the slope is right. The line is going to be rising. From left to right, the line is going to be rising, right? So the line rises. The line rises from left to right because the slope is positive. So that's the answer to that. All right, now let's look at 14. So once again, it says find slope. Okay, so let's think about this. So your x value is 7/6, and then you're at negative 8, right? And then your x value is 7/6 again, and then you're at positive 1 over 8. Now notice something strange. It's kind of like one of the first problems we did. See how there's 2 different x values that are both the same. but the y values are not both the same, that means that this line, when you plot the x value of 7/6 right there, then your y value is going to be at -8, right? So it's going to be like actually down low, right? So it's like down there. Then when you plot this second point, your x value is going to be 7/6 again. So it's going to be in the same place horizontally, in the same place. But vertically though, it's going to be at 1/8. So it'll be like right above the x-axis, right? So the y, so it's going to be going straight up from because the x-axis value was 7/6 both times, and it never changed. So, but the y value started to get bigger. So if it went from -8, which is really low, up to 1/8, which is a positive number. So that's actually a vertical line. Well, vertical lines, they don't actually move forwards or backwards. They're just vertical. So the slope of a vertical line is called undefined slope. So I'm going to say m equals undefined. And then indicate whether the line is vertical or horizontal or whatever. Well, this is vertical, right? So this is a vertical line. Perfect. Now, let's try problem 15. So problem 15 says f of x, which technically is like saying y, equals -3/4 x plus 7. And it says to find the slope. It says to find the slope and the y-intercept. So first of all, the slope is this number right here. So the slope is the number that's in front of x when the equation is in that form. So that's an easy answer. So the slope is that. And then the y-intercept is the number that is not beside x. So the y-intercept equals 7. So that's also easy. But then you're supposed to graph the problem though. So then I have to graph the problem. And the way that I graph the problem is I start with the y-intercept. So you kind of work your way backwards. So start with the y-intercept. So on the y-axis, you'll go to 7. So 1, 2, 3, 4, 5, 6, 7. And then from that point, you're going to count carefully. -3/4 means you go down 3. So go 1, 2. Hold on, let me make this easier to see. So you go 1, 2, 3. That's 3 down. And then you go 4 over. So 1, 2, 3, 4. And then you plot a point at that point. So 1, 2, 3, oh, sorry, right about there. So then that's your second point, and then you draw the line, which if you're doing this on the computer will actually draw the line for you. Once you've plotted the second point, it'll draw the line for you. So there we go. Now, let's go to problem number 16. So problem number 16 says y equals -4/5. Now, notice there is no number that is in front of an x. So when it asks you what the slope is, or the m or whatever, so the slope is called m, or just slope for short. There's no number in front of any x. So that means the slope is just 0. And the reason it's 0 is because you could technically say that this is saying y equals, since there's no x, you could say y equals 0x minus 4/5, right? Because there's no x's. So that technically there is a 0 in front of the x. So the slope is at 0. And then the y-intercept is a number that's not in front of x. So the y-intercept equals -4/5. So that's easy. So y-intercept equals -4/5. And then you have to graph the problem. So what you do is you just graph on the problem -4/5, which, by the way, -4/5 is about equal to -0.8. So you go to negative, so 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So you go to -0.8, and then since the slope is 0, that means it's horizontal. So -8, you just draw a horizontal line like that. So that was simple. Then let's try 17. So we need to find a line that is passing through 15, -5, 15, and -2, number 9. Now the interesting thing is there's actually a famous book called Passing Through or Passing Through by Louis L'Amour. So you should check that book out and read it. So we're doing the passing through problem right now, which is named after a famous book. So how do you find, this is one of the most important problems in algebra, how do you find the line that's passing through 2 different points? So here's the 2 points. We need to find the equation of the line. What you do is you find the slope of the line first. So remember, we take the second y value minus the first y value, and then we put that over the second x value. And now I'm putting it in parentheses because it's negative. So we put it over the second x value minus the first x value. And then we'll get 9 minus 15, which is -6. And then we'll get -2 minus -5. But look, if you subtract a negative, technically you're really just adding. So it's really just -2 plus 5. And -2 plus 5 equals 3. So you get -6 over 3. -6 divided by 3 just equals -2. So the slope equals -2. Now, I'm going to show you an amazing formula. We're going to use something called the point slope equation. The point slope equation is called y minus the first y value equals m, which is the slope, times x minus the first x value. So you see the first x value is -5, and the first y value is 15. So, and we know the slope is -2. So when you plug in those numbers, you're going to get y minus y1, which is 15, equals m. M is -2, right? Oh, hold on just a second. M is, just a second. M is -2, so -2 goes right there. And then x1 is -5, so I'll put that in parentheses. So there we go. So everything that's in red are just the numbers that I plugged in. The y1, the first y value, and the x1, the first x value, and then the m, which is the slope. Now, I simplify this, so I get y minus 15 equals -2 times x minus -5 is really x plus 5. This is your answer to the first part of the problem. So you just type in that answer because it says, what is the point slope form? So that's this point slope form of the line. So then in the next part of the problem, it says find the slope intercept form. So how do you find the slope intercept form once you have the point slope form? Well, let me erase this top part of the problem. There we go. And the point slope form changing into the slope intercept form. Well, all you do is you just simplify it. So if I write down the y minus 15 again, let me actually change to blue so you can see this easier. Then on the right side, I'm going to distribute the -2 times x, which equals -2x. Then -2 times +5 equals -10. And then I'm going to add 15 to both sides to get rid of that -15. And then I'll have y by itself. So y equals -2x plus 15 minus, -10 plus 15 is +5. So this right here is that's almost but not quite the function for the problem. All you have to do is change the y into the name of the function, which is called, in function notation, the y is f of x. So you just say f of x instead of y equals -2x plus 5. So your answer actually looks like that. And that's your review for the Chapter 2 test. And I hope that helps you a lot. And I hope you have a wonderful, wonderful week. And I look forward to hearing from you again. Have a wonderful day.